Hi, everyone. So today we're going to be looking at integrals that are a bit more difficult than what we've seen previously. So in the previous lectures, we've been looking at trig integrals, like with tan and cos and sine and all of those. And we've been looking at integrals involving the power rule for antiderivatives. Okay, so these were very simple. So now we're going to look at something a bit more difficult. And these involve some more integration techniques. Okay, so these will help you solve these types of integrals. So today we're going to be looking at the first of these techniques, and that is u-substitution. Okay, so we're given some complicated integral, and then after doing a little substitution or change of variables, we will see that we can convert the difficult integral into something that's a lot simpler to do. Okay, so let's get started. Okay, so the first example is just to illustrate the idea of u-substitution. And then with a few more examples, you'll get the idea of what we need to do. Okay, so number one, let's say we want to integrate 2x square root of 1 plus x squared dx. So what you from what you currently know, this is very difficult to do. Okay, we've got a product of two things. We can't expand it out into a polynomial. We can't write it in terms of powers. We're pretty stuck. But if we notice this square root here, remember we can write square root as something to the power 1/2. If we can write this inside part simply, so if we get rid of this complicated inside part, then everything goes back to what we know before. So let's just make a little note. So the square root of something that's simple. However, we've got this inside part that makes it complicated. Okay, so we've got a simple outside function, but a complicated inside function. Okay, so what we do is we do a little change of variables where we let this new variable u, we set that to be the complicated inside function. So we let u be equal to 1 plus x squared. Okay, so we're changing the variables from x to u, but we need to do that for all of the x terms. So all of these x terms are going to change to u, but this differential over here also needs to change. Okay, so this dx needs to change to du, because we were working with x variables, now we're working with u variables. So how do we do that? Well, we know from your previous differential calculus that du is equal to du by dx dx. Okay, remember you should have done the differentials. So now du is equal to du by dx times dx. So if we differentiate this, we're going to get 2x dx. That's going to be our du. Now notice that this 2x dx here is exactly what we needed to replace this 2x dx. Okay, is there anyone that does not see that? Okay, anyone confused so far? Okay, so now this integral in terms of x can now be written as an integral in terms of u. Okay, so what we're doing here is we are replacing the x variables with u variables. So we're doing this substitution over here. Okay, so where did we get the substitution from? Well, I said we let u, our new variable, be the complicated inside part of this function. So we know that the square root of something is a simple function, but this inside part, the 1 plus x squared, that's complicated. We want to get rid of that. So we let u be equal to 1 plus x squared. That is what we're going to use to change the x variables into u variables. But we've also got this dx term that we need to worry about. How do we get dx? Well, we start off with u is equal to 1 plus x squared. If we differentiate both sides, we get du is equal to du by dx times dx. And du by dx is 2x. So that's how we get that. But notice that this 2x dx appears in our integral. We've got here 2x dx. Okay, so we're going to substitute what we know now. So this is going to become the integral. The square root of 1 plus x squared is now going to become the square root of u from this over here. So that will be the square root of u. And 2x dx, well, that's going to be du. Okay, so let's just write down what we substituted. So the square root of 1 plus x squared, that is the same as the square root of u. And 2x dx, that is the same thing as du. So I've just substituted those two things into the integral. Okay, any questions so far? Okay, so after the substitution, we see that our complicated integral becomes a very simple integral. It's just the integral of the square roots of u. We've done that many times now. So this is going to be the integral of u to the 1/2 du. Remember how we did this? We add 1 to the exponent to make it 3/2. Divide by 3/2, which is the same thing as multiplying by 2/3. So we get 2/3 u to the 3/2 plus c. Okay, but we're not done yet. We need to substitute back to get our original x variables. So we need to substitute back u is equal to 1 plus x squared to go back to x variables. So we do that. So instead of a u, we're going to replace that with 1 plus x squared, which is what we started with. So this is going to become 2/3 1 plus x squared to the 3/2 plus c. Okay, and that is how we do a u substitution. Okay, because we're doing this change of variables from x variables to u variables. Okay, are there any questions about this process? Okay, anything at all? Okay, let's take a look at another example then. Okay, so this is example number 2. Okay, okay, sure. Let me just do that example again then. Okay, so we have the integral 2x square root of 1 plus x squared dx. Okay, so we know that the square root of something, that's easy to integrate. If I ask you integrate the square roots of x, you can do that fine. However, in this case, we've got this complicated inside part. So we have a complicated inside function. Okay, so this 1 plus x squared on the inside of our function makes it complicated. Okay, we don't want it there. So what we do is we let u be this complicated inside function. Okay. In other words, u is equal to 1 plus x squared. Whatever your complicated inside function is, you let that be u. Okay, so now we can convert all of the x variables into u variables because we've got this equation here to do that. But we can't just convert that. We also need to convert the differential. So we need to write this in terms of u. Okay, so how do we do that? Well, we've got the u function, so we can use the u function to find du and dx. So du, okay, so we had dx, that's what we had before. Now we want du because we want everything in terms of u. So again, we're just doing the change of variables from x to u. So the function needs to change from x to u, dx needs to change from x to u. So that's what we're doing here. So du is going to be du by dx, dx. So what is du by dx? We differentiate u with respect to x, and we're going to get 2x dx. Okay. So look here, we've got 2x dx, 2x dx. So that combined, the 2x dx in our original integral is now du. Okay, so we can rewrite the integral. So the integral of 2x square root 1 plus x squared dx, we can just swap some things around. We can write this as the integral square root of 1 plus x squared, that's the first part, times 2x dx. Okay, so this first part, the square root of 1 plus x squared, that is going to be the square root of u. Okay, from here, we've got u is equal to that. So square root of u is square root of 1 plus x squared. So that's over there. 2x dx, that is right here on the second line. du is equal to 2x dx. So that's du. So this now becomes the integral of the square root of u, and then we have du. Okay, so now we can integrate this. This is going to give us 2/3 u to the 3/2 plus c. Okay, but we'll make a little note. We don't want u, we want x. So instead of writing this in terms of u, we need to substitute the original expression back. So u is equal to 1 plus x squared. We just put that back. So this becomes 2/3 1 plus x squared to the 3/2 plus c. Okay, so that's all the steps that we need to follow. Okay, does that help you out a bit? Okay. Okay, let's take a look at some more examples. Okay, so the thing with this u-substitution, you need to do lots of examples to get lots of practice, and then you'll get really good at it. Okay, so In the tutorial, I put some examples there. In the notes, there's some more examples. And in those extra notes that I put up, there's even more examples there as well. You have to do as many as you can to get some extra practice. Okay, especially with this u substitution, you need to do as much practice as possible. Okay, let's look at the second example. So we have the integral of x cubed, and then we have cos x to the 4 plus 2 dx. I'm going too fast. Okay, sure, I can slow down with this one. Yeah, if I'm going too fast, please let me know. Okay, just send a message or raise your hand, and then I can slow down for you. Okay, so we've got this integral. What you should notice immediately is that this inside function makes it very complicated. If I gave you cos x, that is simple. Yeah, it's a very simple function, nothing wrong with that. If I gave you cos of x to the 4 plus 2, you would tell me that this is complicated. Okay, I'm sure we can all agree that the second function is more complicated than the first one. Now, why is it complicated? Well, it's complicated because of this inside function here. So this inside function makes it complicated. Okay, so this inside function x to the 4 plus 2 makes it complicated. Okay. Okay, so with more and more practice, you will be able to spot these complicated inside functions a lot more quickly. Okay, so please do all the tutorials, all of those extra notes, examples, and in the other notes as well, do all those problems, and then you'll be able to spot these very quickly. Okay, so just to recap, we've got cos of x, that's simple. However, in this integral, we have cos of x to the 4 plus 2. That's complicated. Why is it complicated? It's this inside function here. This is what's making it complicated. So how do we simplify things? Well, to simplify the function, we use u is equal to that complicated function. Because if we say u is equal to the complicated bit, well, then it's going to go away. So u is equal to x to the 4 plus 2. Again, that is this bit here that made it complicated. You always do that. Whatever is making the function complicated, that will be u every single time. Okay, so we've got the transformation between x and u. Now we need to find du. Okay, it's the same steps every single time. So du is du by dx. Okay, same as we did before. So what's du by dx? We just differentiate what we're given here. So the derivative of x to the 4 plus 2 is going to become 4x cubed dx. Okay, so I've just done the derivative there. Okay, but notice x cubed dx. So we've got x cubed, we've got dx. We've got x cubed, we've got dx. But we don't have 4. We don't have 4 in the original integral. Okay, so just check, we've got du is equal to 4x cubed dx. So if we go back to our original integral, we've got x cubed, we've got dx, but there's no 4. This 4 is not shown. So what we have to do is take this 4 to the other side of the equation. So now we're going to have 1/4 du is x cubed dx. This right-hand side part we do have. Okay, so that is what shows up in our integral. The 4 is from, this 4 here is from this du by dx. So u is equal to x to the 4 plus 2. So du by dx is 4x cubed. This bit over here. Okay, so we're just differentiating u. Okay, I've got the du by dx there. No, sure, no worries. Okay, so now we've got everything we need. X cubed dx, we've got x cubed dx. X to the 4 plus 2, we've got x to the 4 plus 2. Okay, we've got everything we need. So let's substitute in what we know, and everything should be nice and simple. So the integral of cos x to the 4 plus 2, and I'm just going to write this differently. So the x cubed, I'm going to take to the end, times x cubed dx. We can rewrite this as the integral of cos. What is x to the 4 plus 2? X to the 4 plus 2 is u. What is x cubed dx? X cubed dx is 1/4 du. Okay, so I've just substituted the two pieces that we needed. Okay, so just to reiterate here, x to the 4 plus 2, that's u. X cubed dx, that is 1/4 du. Okay, is there anyone not following that?
Sir, could you please go over this example again?
From where? Which part are you lost from?
From the substitution of u.
Okay, sure. Okay, so let's just go over here. Okay, so remember, how did we get u? U is this complicated inside function. Whatever the complicated inside function is, you let that be u. Okay, now remember how integrals are made. You've got a function and you've got dx written over here. So if your variable is x, you're going to have a dx. If your variable is u, you're going to have a du. So what we are doing is we are going from x variables to u variables. So we don't want dx anymore. We now need du because that's part of our new variable. So how do we get du? Du is equal to du by dx, dx. You just need to remember that. Okay, so du is equal to, what is du by dx? Well, we differentiate what we're given. So u is equal to x to the 4 plus 2. How do we differentiate that? Well, the derivative of x to the 4 is 4x cubed. The derivative of 2, that's going to be 0, so we don't need to write that down. And that is dx. Okay, but if we look back at our original equation here, the original integral, we've got x cubed dx. Okay, that's what we've got there. However, here we've got an additional 4. You see, this 4 comes in our du, but it is not shown in our original integral. Okay, that's not shown there. So what we need to do is take it to the other side. So let's just move this. Okay, so again, there's a 4x cubed from the du by dx. but our original integral doesn't have a 4. There's no 4 there. So we need to take it over to the other side. So 1/4 du is equal to x cubed dx, which is what we have. We go back to the top, x cubed dx, that is what we've got here. Okay, so we can use this now to redo our original integral. So remember, it was the integral cos x to the 4 plus 2 x cubed dx. This part here, x to the 4 plus 2, that is u. X cubed dx, this part here, that's going to be 1/4 du. So that is how we change from that's how we change from x to u. We need to change the function to be a function of u. We need to change the differential from dx to du. So these are the two things we need to do. Number 1 and number 2. Okay, is that all right?
Yes, sir.
Okay, awesome. So now we can just write this as the integral cos of x to the 4 plus 2, that's going to become cos of u. X cubed dx now becomes 1/4 du. I've just replaced it with what we found. So this is number 1. And then I'll put number 1 there. This is number 2. I'll put number 2 there. So I've just done the replacement. So here, this part is number 1. This part is number 2. Okay, I've just done 2 replacements. Okay, so now this 1/4 we can take out from our properties of integrals that we went over. This becomes the integral cos of u du. Okay, what is the integral of cos?
Sine.
Yeah, that's it. Yeah, you got it. So it's going to be sine. So this will be 1/4 sine of u, and then don't forget your plus c. Okay, but this is in terms of u. Okay, we want it in terms of x. So we just do a substitution to what we had originally. Remember, u was x to the 4 plus 2. So we just put that back. So this is equal to 1/4 sine of x to the 4 plus 2. And then plus c. Okay, so that's all the steps that we need to do. So let's just go over this again. So we're given this function here to integrate, and it is complicated. Why is it complicated? Because our cos function has a complicated inside function. It's like this, you know, when you have f of g of x. If you have something like that, this inside part makes it complicated. So what we do is we try and remove that complexity by saying u is equal to that complicated function. So here, u is equal to that complicated function inside cos. Okay, so that part's done. Next, the integral is made up of 2 parts, right? We've got the function and we've got the differential, this dx here. So if we are changing from x to u, the function needs to change from x to u, and the differential needs to change from x to u. So we've got u, but what we really want is du, because that's what we need in the integral. So we've got u, now we need to find du. That's this thing over here. Okay, so that we can put it at the end of our integral. How do we get du? Well, du is equal to du by dx. Okay, so that's from last year calculus. So du by dx, we just need to differentiate the u function. So the derivative of x to the 4 plus 2 is going to be 4x cubed plus 0. But we don't need to put the 0 because it doesn't add anything. So we get du is equal to 4x cubed dx. Okay, good. But if we look back at our original integral, there is no 4x cubed dx. What we actually have is x cubed dx. Okay, there's no 4 over there. So how do we fix that? We take this 4 and we move it to the other side. Okay, so the 4 on the right-hand side becomes 1/4 on the left-hand side. So now we have x cubed dx, which is exactly what we've got here. We've got x cubed dx. Okay, it's underlined in red. Okay, so those are the two pieces we need to rewrite the integral. We know that u is equal to x to the 4 plus 2. That's part 1. And part 2, we know that 1/4 du is x cubed dx. So all we need to do is substitute part 1 and substitute part 2. And that's what we do over here. We see cos of x to the 4 plus 2. This inside part here, that's going to be u because of our substitution. X cubed dx, that's going to become 1/4 du from our previous work above there. So we make the substitution, and now everything is in terms of u. So this is in terms of u, which is good because it's nice and simple. The integral of cos, we can do that. We've done it so many times now. So the integral of cos becomes sine. So the integration is done. Very easy integration. However, we still have u over here. We still got u, but we don't want that. We don't want things in terms of u. We want to go back to our original x. So we want our original x variable. How do we go back to our original x variable? Well, u is equal to x to the 4 plus 2. That's what we started with. So we just put that back inside. And then here we go. We plug it inside the sine function. And now the whole thing is in terms of x. Okay, which is what we wanted. We wanted everything in terms of x. Okay, are there any questions about this one? Okay, see, it's not too bad. You just need to let u be the complicated part of your function. That's step 1. Step 2 is you find your du. Okay, that's your step 2. And then step 3, you just substitute that so that everything is in terms of u. And then you can substitute back to make everything back in terms of x. Okay, let's look at one more example. At number 3, we have the integral of the square root of 2x plus 1 dx. Now, we see that we've got the square root, but we've also got an inside function. This inside function is making our lives difficult. Okay, so this is our inside function. Okay, so what did I say we must do with the inside function? We let u be the inside function. So let u be equal to 2x plus 1. Good, that's step 1 done. Next, we don't want dx, we want du. So du is equal to du by dx dx. So what is the derivative of 2x plus 1? It's going to be 2. So this will be 2 dx. But we've got a problem. We've got a 2 dx, but in our original integral, there is no 2 dx. We've just got dx. So we need to take this 2 and put it on the other side. So the 2 becomes a half. We have 1/2 du is equal to dx. So we've got part 1 done. We've got part 2 done. So what we need to do is substitute part 1 and part 2. So the integral of the square root of 2x plus 1 dx now becomes the integral. The square root of 2x plus 1 will now become the square root of u. Dx will now become 1/2 du. So this was part 1, this was part 2, this bit over here. So this is going to be 1/2 the integral of u to the 1/2 du. That's going to be 1/2 times 2/3 u to the 3/2 plus c. And that will be 1/3 2x plus 1 to the 3/2 plus c, where we substitute back. Okay, so we're running out of time now, so I'm going to leave it at this point here. Please take a look at the tutorial questions on u-substitution. Okay, so try them out for today. That will be the homework. If you have any questions about those, please let me know. Okay, and then I will upload this video and another video with some more examples later today. Okay, and please remember that we have the TUT quiz this Wednesday, okay, on FTC 1 and 2. Okay. That's it for today. Please look out on Learn 2022 for these lecture videos that I'll be posting. Okay, and please do the homework today. Okay, I'll see you all tomorrow for the tutorial and the tutorial test. Bye, everyone.
Bye.
Showcase.